Hi all, welcome to my channel.
Hey guys, and welcome to a new video. In this video here, we're going to do live instance segmentation with the new YOLOv5 model. We will go inside Google for instance to see that and we can model set 88 around model cells. We can as a product data taker from public data. Right now, I'll set data just set now main out and so on. If you just can actually see, we can also using the lot and now we go. We have down here, but we still relative. We just do our running can have like 97% confidence score. Really, my 9 up, so we can import nothing. Model. I will model the same one. Called segmentation mask on this live inference. We can see we run around like just once. So we have the cocker cup. So this is the cup, standard cup. I'm doing. Creating really nice V8 model, live button, and film notification on this. Hey guys, and welcome to a new video. In this video here, we're going to do live instance visualization model. First of all, we just connect to the NVIDIA or like a GPU runtime. Verified that we actually have a GPU assigned to our runtime. So here we can see that we have at test that's T4. Then we're going to install YOLOv5. We're basically just going to pip install Ultralytics. So these are the creators behind YOLOv5. And then it will basically just install YOLOv5 in that way. We can import the different modules, OS, IPython for actually displaying some image examples. And then we also import the YOLO model from Ultralytics. So we just run this block of code, and then we'll likely be able to use this YOLOv5 model and train it on our own custom instance segmentation dataset. So first of all here, I'm just going to show you an example of how we can do instance segmentation with a single example on an image with an already pre-trained model. So citation, prediction, and then we basically just specify the model. So we're going to use set up our dataset, train it on our own custom segmentation needs inside running nothing. It's is where I go down. We just choose the format. You'll set our whole dataset into this directory. Set our data. The 8 model will be edited just like that. Down here at the bottom, down here, starting with the Mina on our model. So we just change the mode to validation, and we specify the path to the model with the best weights. We can also go over here to the left, and inside our train, we can go inside the weights, and then we'll have the best model and the last train model. So basically, I'm just going to download the best model because then we can download it, we can import it into our own Python file and do live inference with it. And we're going to verify through the model, choosing a particular basically we're just running through the top, not almost like with digital webcam, or to show how we can import this model, run live inference on our webcam. So again, we just need from Ultralytics import YOLO, so we can import the model, and then we also have this detection predictive class, which I'm going to show you in another video how we can modify to change some of the predictions if we want to do our own visualizations, extract information, and all those different kind of things. So make sure to hit the subscribe button and turn notification under the video so you will get notified when I upload a new video where we're actually going to modify the predictions and how we can use them in our own projects and applications. Here we basically just have our model. We set that equal to the YOLO class here. We specify the path, so I call the model, I renamed the model to cop instance.pt, so this is a PyTorch model. Import the model, it will create the model, and then from that we can just call the predict method. We specify the source, so this can either be images, folder images, video files, and also if we specify a 0, it will be on our webcam. Show equal to true, so all these parameters here are the exact same ones as we did, and we can throw into the YOLO command into the Colab. So we set show equal to true, so we actually visualize our result, and our confidence score we set that equal to 0.5. So if our predictions has a higher confidence than 0.5, we're going to show them, and if they're lower, we basically just discard the detections for that. Now we can actually just run the program and see the results. I'm really excited to see how this will actually work at the hand painted cup a bit further down here. this image sequence. Hey guys, and welcome to a new video. In this video here, we're going to do live instance segmentation with the new YOLOv5 model. We will go inside Google Colab. I'll show you how we can have our own dataset, train it on a custom dataset for instance segmentation. So basically just go through the whole Google Colab notebook. We're going to train our own instance YOLOv5 segmentation model. Then we'll export it, import it into our own Python script, and do live instance segmentation inference. So this is going to be really crazy, and we can even run it in real time. So when I jump into Google Colab, I'm going to show you how we can train this YOLOv5 custom instance segmentation model. First of all, we just connect to the NVIDIA or like a GPU runtime to just verify that we actually have a GPU assigned to our runtime. All the mean error positions are increasing, so this acts like a really nice result. And then inside our dataset variable, we can just call location. Then it will get the path to our dataset, and train these YOLO train. Then we'll have both the box and curve, the particular inside segment, and then we have our train. Two files will also be inside our runs. We go inside segment, and then we have our train. Then we'll have both the box F1 curve, the precision recall curves, some mask curves, you have the diffusion matrix, and then also with the result down, so the background equals matrix, doesn't matter. We can also see the results for the training graphs or like the loss graphs, and the mean average starting with the one box. It took like a fifth fold. We just changed them. We can also go over here to the left, and inside our train, we can go inside the weights model, because with our webcam model, like new predictions on like works as intended. Our webcam, all the images in our validations with matrix for this data setup. These need to complement because we have a pretty good since all here you can have segment loop on. I'll just scroll up to the top to start with. We're going to run it like link up take available code we just need from Autolytics implant and modify the device here into as a run a program. Okay, really nice results. We can see we have the happening. I'm actually this will actually work running real time. time from a webcam. Then we can see using masks sometimes this I'm going to crazy. I'm just trained in the future. Hey guys, and welcome to a new video. In this video here, we're going to do live instance segmentation with the new YOLOv5 model. We will go inside Google Colab. I'll show you how we can have our own data set, train it on a custom data set for instance segmentation. So basically just go through the whole Google Colab notebook. We're going to train our own instance YOLOv5 segmentation model. Then we'll export it, import it into our own Python script and do live instance segmentation in Burn. It is going to be really crazy and we can even run it in real time. So when I jump into Google Colab, I'm going to show you how we can train this YOLOv5.
YOLOv5 is in this course, you want to be mostly to learn Jump 45 is created by Ultralytics team, the company behind YOLOv3 and YOLOv5, two repositories that collectively have almost 45,000 stars on GitHub on the day of recording. So pretty serious contributors to open source, if you ask me. Of course, both of those projects had their issues. Lack of paper that irritated large part of data science community. Lack of pip package that make it really hard to deploy the model that irritated large part of engineering community. Apparently both of those issues will be solved in the YOLOv5 project, time will tell. But in the meantime, let's just jump into the code and train some models. Before we start, just a quick disclaimer here. The whole library feels a little bit underbaked, so I fully expect some small API changes.
Custom instance segmentation model. First of all, we just connect to the NVIDIA or like a GPU runtime to just verify that we actually have a GPU assigned to our runtime. So here we can see that we have a test.c4. Then we're going to install YOLOv8. We're basically just going to pip install Ultralytics. So these are the creators behind YOLOv8. And then it will basically just install YOLOv8 in that way. We can import the different modules, OS, IPython for actually displaying some image examples, and then we also import the YOLO model from Ultralytics. So we just run this block of code, and then we'll actually be able to use this YOLOv8 model and train it on our own custom instance segmentation dataset. So first of all here, I'm just going to show you an example of how we can do instance segmentation with a single example on an image with an already pre-trained model. So this is just a pre-trained model on the Cocoa dataset. We basically set the task here equal to segmentation. If you want to do detection, you can set that task equal to detection. The mode is equal to prediction, and then we basically just specify the model. So we're going to use YOLOv8 and then the large model for segmentation. We set a confidence score of 0.4, and then we basically just specify the source here as well, which is a single image that we want to pass through our model. Then we can run it and just directly display it, or we're going to set up our dataset, train it on our own custom dataset, the YOLOv8 model, and then we can export it. We can see the results here first in Google Colab. Then we'll export the model, import it into our own Python script, and do live instance segmentation inference from our webcam. So basically here we're just setting up. First of all, we need to download the models the first time we run it, and then after that we can just display the image. So we just go inside run, segment, predict, doc, and then we just specify the image. Here we see a really nice segmentation. So this is a prediction on an image that has not been trained on. So we have a person. It is it's a really nice segmentation. Setting up, first of all, we need to download the models the first time. We set up our dataset, train it on our own custom dataset, the YOLOv8 model, and then we can export it. We can see the results here first in Google Colab. Then we'll export the model, import it into our own Python script, and do live instance segmentation inference from our webcam. Basically here we're just setting up. First of all, we need to download the models the first time we run it, and then after that we can just display the image. So we just go inside run, segment, predict doc, and then we just specify the image. Interference from our webcam. Basically here we're just setting up. First of all, we need to download the models the first time we run it, and then after that we can just display the image. So we just go inside run, segment, predict doc, and then we just specify the image. Here we see a really nice segmentation. So this is a prediction on an image that has not been trained on. So we have a person. It is it's a really nice segmentation of the person. We have a backpack, right? I should already go. So now we're going to go inside the dataset, go inside YOLOv5. So I basically have a dataset where I have labeled it for instance segmentation. You can just go inside my projects here. You can go ahead and use my project as well here from the YOLOv5 website. If you just go down, we can see we have this cup segmentation for instance. Segmentation. You can also go inside the universe if you just want to use like a public data set. We can set it up here for instance segmentation. You just choose this, and then you will get a bunch of examples of instance segmentation data sets. You just go in, take one of these, and then you will do the exact same process of exporting the data set that I'm going to show you now with my own data set. So we just hit export, and then we just choose the format. That I'm going to show you now with my own data set. So we just hit export, and then we just choose the format, YOLOv5, hit show download code, continue. It will export our data set, zip the files, and then we just get this code snippet. We copy it and and we paste it into our Google Colab. So I just copy paste it in here. When we run it, it will act like unzip our whole data set into this directory.
So now that we have a train model, you're going to get a JSON. This is helpful and look at all of the different code snippets that we have in Python. That way you can get started for your and I'll use my chess images. How to run somewhere on the internet. Or you'll need to change things like your monkey. So now I'm showing you how to grab that information from the download code from your dataset and the model version number in multiple places. Then your API key here. Remember again, I'm showing you my API key in this example, but again, do not share your private API key inference directly on this to your. It can only be your publishable.
It will act like unzip our whole data set into this directory, and then we will have it over here to the left. So now we can see that it had extracted the data set over here to the left. You can see the COP segmentation. We have a test, train, and validation set. Google Colab the file with my own keys, and then you can load this code in here. When we run it, it will act like unzip our whole data, and then we just get this code snippet, we copy it, and we paste it into our Google Colab. So I just copy paste it in here. When we run it, it will act like unzip our whole data set into this directory. and then we will have it over here to the left. So now we can see that it had extracted the data set over here to the left. We can see the cop segmentation. We have a test, train, and validation set. Here we can just see all the images and all the labels for our training set, test set, and validation set. So now we have everything. We have our YOLOv8 model. We also have the data set from RoboFlow. So now we can basically just go in and train the YOLOv8 model. We have this YOLO command. We set the task equal to segment, and then the mode will be equal to train because we want to train this new. New model on our custom dataset. Here I choose the large model, the YOLOv8 large model -seg for segmentation. And then inside our dataset variable, we can just call location, then it will get the path to our dataset. And then we basically just throw in our dataset in that way. We specify the number of epochs and also the image size. So when we run this block of code, it will actually train our custom YOLOv8 model on this data set that I just showed you. So we're going to segment out cops in our images. First of all, we get a summary of our architecture and our YOLOv8 model. We get a bunch of convolutional layers, some upsampling layers, and also some concatenation layers. We can see the optimizer, so we're using HTD with a learning rate of 0.1. We have some data augmentations and all those different kind of things. Then the training should start down here at the bottom. We have epoch 1 out of 15. You can see the box loss, segmentation loss, class loss. We should also get some mean error position losses and so on. But then it will basically just run for 15 epochs, and then we can look at the results after.
Engineering community. Apparently both of those issues will be solved in the YOLOv8 project, time will tell. But in the meantime, let's just jump into the code and train some more. Before we start, just a quick disclaimer here, the whole library feels a little bit underbaked, so I fully expect some small API changes to be are part of the daily base case. So to just confirm that, let's run NVIDIA semi command. If indeed we have access to the GPU, we should see similar result after that command is being run. The initialization takes a little bit of time, but yes, we have the access to the GPU, Tesla T4, we are ready to go. Now let's create a small helper variable called home that will allow us for easier management of paths to datasets and other images. And at this point, we are basically ready to install the actual YOLOv8 package. According to the documentation, there are two ways to do that. We can either use pip As I said, this is the first iteration of YOLO that have official pip package, or we can go the usual route by just cloning the repository and installing the dependencies. I myself select the first one, so we are going for pip install Ultralytics, but in a notebook you can do whichever you want. Just make sure to comment the first one, and then there are two ways to do that. We can either use pip. As I said, this is the first iteration of YOLO that have official pip package, or we can go the usual route by just cloning the repository and installing the dependencies. I myself select the first one, so we are going for pip install Ultralytics, but in a notebook you can do whichever you want. Just make sure to comment the first one and then comment the second one if you go for git clone, just to make sure that you don't run both of those cells in a single environment. Now we can simply import YOLO from Ultralytics, so let's do that now. And if we don't see any exceptions, everything works properly. As I always say, the best way to make sure that everything was installed properly is to run your app. We have two LIS terminal. Typically, it has a concept of task and the mode. And this is very important because that's how they compact everything that was a separate script previously into or the next to a other image command. Then it's, and after that, direct our image and predict. Let's switch the as if you already have. Let's go to roboflow.com. Now let's say that we will detect football players, and the name of just drag and continue button. Let's use the match. Usually, when the labeling job is created, you will get redirected the model to think tasks. If you are a friend, like I said, a man just. smooth mode. Now, after a few minutes, depending on your internet connection and the size of your dataset, you will end up on this screen. From here, you can assign labeling tasks. If you work independently, like myself, you have no other choice, you need to assign it to you. If you have friends, you can invite them into the workspace and they can help you out with annotation. Like I said, in my case, I just select myself and click Assign Images. When the labeling job is created, you will get redirected to this screen, and from here you just click on the first image and just start labeling. The annotation process itself is pretty straightforward. You just draw bounding boxes around the object that you would like the model to detect. The work is pretty tedious, but the good news is that you don't need to annotate the whole data. So you just can annotate part of that, train the model, and use that model to annotate the rest of the images. With every iteration, the quality of predictions should get better and better. We already have tutorials on how to do that, so you can look for the links in the description below and in the card in top right corner. When the annotation process is done, you just submit your images for review. And here you can approve or reject the annotations. Right now I have all my images annotated, so I'll just approve them all and add them to the dataset. Now I'm ready to generate the first version of the dataset. So I got redirected to generate new version tab. And over here, I can apply all sorts of transformations. For example, resizing. Now let's add augmentations. I don't want to go too hard, so I'll just add a horizontal flip for the images. I press continue and generate. And after just a few minutes, my dataset should be ready. As we already have the dataset, there is nothing else for us to do than just download it into our environment and start training. Now we can use one of the features that we added specifically for YOLOv8 launch. We can press that button over here, and that will generate a code snippet that will allow us to download our freshly created dataset in YOLOv8 format. We can just copy it and paste it into the notebook. So let's do it right now. I can just highlight that text, paste it here, press Shift-Enter, and the downloading will start immediately. Keep in mind that that code snippet contains your API key. It is not visible in the UI, but when you paste it, it will be in plain text. So just watch out, make sure not to commit that accidentally into your repository, especially if that's a tablet. Looks like the download of the dataset has completed, and now the only thing that is still left to do is to execute the training itself. Let me just adjust a single hyperparameter, limit the amount of epochs from 100 to maybe something around 25. This is a pretty large dataset, so that will take like an hour to complete. Shift-Enter, and the training can start. All right, the training has completed, and now the time has come for us to review the results of the training. So the first thing that we'll be doing is to take a look at some charts produced by YOLOv8 that are saved into the runs directory. That will tell us a little bit more about the training process and the expected accuracy of our model. First, let's take a look at the confusion matrix. So confusion matrix is a chart that shows us how our model handles different classes. So for example, if we talk about goalkeeper, 74% of the time it's detected correctly and it's classified as a goalkeeper. However, 26% of the time we get the bounding box, but the goalkeeper is incorrectly classified as a player. On the other hand, in case of the ball, which is quite small object and it's hard for the model to detect, we only detected 26% of the time. However, 74% of the time, when the ball is there, we are simply not detecting it. All classes apart of ball are detected correctly most of the time, and given the fact that we only train for 30 to 40 minutes, I am more than satisfied with the result. Now let's take a look at the chart displaying key metrics tracked by YOLOv8 of the detection. So over here, I'm usually mostly interested in box loss and class loss for train and validation data. We see that the behavior is correct, the model is converging, and it's clear right now that the training could take even longer and we will get even better results. And the curve on those charts is still pretty steep. That means that we still would be able to get a lot more from those models. Usually the sign that we are training for too long is very flat part at the end of the chart. That means that you're just burning time on your GPU, but your metrics are not improved. The last image contains example of model predictions on the validation batch. Those images are not used strictly for training, so it's always nice to take a look and kind of like visually confirm that the model is behaving how you expect. Now we can take our freshly trained weights and use them to validate the model. So similarly as before, we will use CLI to do that. The difference is, however, that this time we are using mode val, contrary to mode detect or mode train, and validation script is using the part of the dataset that was not used before, the test dataset. And those are the true MAP metrics that we should care about. Finally, let's take our model and just use it for inference. I will use the same test subset of our dataset, but this time I just want to see the results. So as usual, the model is being loaded into the memory, and because we are using GPU, the inference is pretty fast. And over here, we can plot a few of those images to see how the model is performing. So this particular result looks really good. The referees are being detected, the goalkeeper is being detected. The only thing that I don't see over here is the ball, but that may be for the reason it's getting terribly occluded by one of the players. Obviously, you can use YOLOv5 not only to run inference on images, but also on videos. So I decided to upload one of the videos that I had on my machine and just run the inference on it. The only difference between this command and the previous command is that this time I passed the path not to the images directory, but to a MP4 file. The rest is exactly the same. I'm just pressing enter and shift, and we just need to wait for the inference to complete. As Google Colab is notoriously terrible at displaying videos in UI, I decided to download the result, and here you have it, a short snippet of what is possible with YOLOv8. Keep in mind that that model was trained only for 30 minutes, and it is actually one of the smallest architecture YOLOv8s. If we would optimize for the accuracy, most likely we would select a larger version of YOLO. However, if you take a look in the logs, you will see that inference on a single frame takes between 12 to 13 milliseconds. That means that the inference at around 80 FPS is well within our reach. Now, before we wrap it up, let me show you one more thing, which is how to deploy your freshly trained model and use it to infer over the API. And all of that magic can happen with just a single line of code. After we trained our model, we just do project version deploy, we pass the model type and the path to our train directory, hit shift enter, and that will basically upload our weights to the server. Then after the upload in the Jupyter Notebook is completed, we can go into our RoboFlow account. Next to the version of the dataset that we are using, there will be a green check mark that basically is here to let us know that the model was successfully uploaded. And the best thing about it is that now when I go into the deploy tab, I can use that model to infer using our hosted API. One of the ways that I can do it is basically by drag and dropping the image into the browser. Let me do that right now. But besides that, I can now infer using the API. From my code base, we provide plenty of snippets in different languages, or I can even spin my own inference server, for example, on NVIDIA Jet. That's all for today. This video is just part one of the whole series that we plan to release about YOLOv8. So if you are interested in instance segmentation, classification, or in general comparing YOLOv8 to previous object detection models, stay tuned for our future videos. And obviously the best choice is to like and subscribe. This way you will get notified about those videos as soon as they will get released. My name was Peter. See you next time. Bye.
Hey everyone, welcome to my channel. This is OpenCV C++ course that is
Առաջին ինձ ոչ մեկ չի իմանալու, որ մեր կուրսն է, ոչ մեկ չի իմանալու, որ դասախոսների կուրսն է։ Այդտենց մի շաբաթ բոլորը գնալու են։ Առաջին ինձ ոչ մեկ չի իմանալու, որ մեր կուրսն է, ոչ մեկ չի իմանալու, որ դասախոսների կուրսն է։ Այդտենց մի շաբաթ բոլորը գնալու են ցուցասրահ, նայեն, չիմանալով թե գործերն են, ու ուրբաթ օրը ամսի 10-ին տենց հայտնվելու ենք մենք ու պարզվելու է, որ մենք ենք ու տենց վերջին օրը նոր տնօրենի խոսք, բլա բլա բլա, այդ ամեն ինչն է լինելու, որը այդ կստեցի դրանք սովորաբար առաջին օրն են լինում, ոչ թե վերջին, տենց սիստեմը ջարդել ենք էլի։ Այդ մի շաբաթվա մեջ, երբ ուզես կարաս գաս։
We're going to segment out cups in our images. First of all, we get a summary of our architecture and our YOLOv5 model. So we get a bunch of convolutional layers, some upsampling layers, and also some concatenation layers. We can see the optimizer, so we're using HD with a learning rate of 0.1. We have some data augmentations and all those different things. Then the training should start down here at the bottom. So we have epoch 1 out of 15. You can see the box loss, segmentation loss, class loss. We should also get some mean average position losses and so on. But then it will basically just run for 15 epochs, and then we can look at the results after. Results. So let's just go to epoch average position of 50, and then for like freeze last one, and then we have our train. So here we're down background. We can also see the results for process that increase here. Also to forward, and we can implement. So here images from the test set, and then we'll use in our validation weight in our easy and then because then we can either go down visualizing the inside our run or double tap on them, and we will get the result. Displaying 5 examples. Let's scroll down so we can see what is been. displaying 5 examples. Let's scroll down so we can see what is going on. I'll just scroll up to the top to start with. Here we can see the Halloween Cup, 97% confidence score. This is Halloween Cup. We get this really nice segmentation mask around the cup. I'm really mind blown about these results. This is just really crazy. They even have like an extra large model, and this large model, I'm going to run it with like almost like 75 frames per second in real time. This is really crazy. We get some false positive up here. Maybe it has a confidence score of 50 or something like that, but we get a false positive here. But again, the other predictions down at the bottom: Halloween Cup 95, hand painted cup 94, the white cup, Halloween Cup. This is also a really nice example. I just analytics import YOLO so we can on live and the segmentation mask. So right now, jumped into Visual Studio Code. I'm going to show you how we can import this model, run live inference on our webcam. So again, we just need from Autoanalytics import YOLO so we can import the model, and then we also have this detection predictor class, which I'm going to show you in another video how we can modify to change some of the predictions if we want to do our own visualization, extract information, and all those different kind of things. So make sure to hit the subscribe button and bell notification under the video so you will get notified when I upload a new video where we're actually going to modify the predictions and how we can use them in our own projects and applications. Here we basically just have our model. We set that equal to the YOLO class here. We specify the path, so I called the model, I renamed the model to cup instance.pt, so this is a PyTorch model. Import the model, it will create the model, and then from that we can just call the predict method. We specify the source, so this can either be images, folder images, video files, and also if we specify a 0, it will be on our webcam. Show equal to true, so all these parameters here are the exact same ones as we did, and we can throw into the YOLO command in Google Colab. So we just set show equal to true, so we actually visualize our result, and our confidence score we set that equal to 0.5. So if our predictions has a higher confidence than 0.5, we're going to show them, and if they're lower, we basically just discard the detections for that. Now we can actually just run the program and see the results. I'm really excited to see how this will actually work running real time from a webcam. Now the program is running. I'm actually really excited to see the results. I'm just going to take out the webcam and let's then do live instance segmentation inference. Here we can see the webcam. We get some really nice results. Images, folder image. images, video files, and also if you and webcam have this detection detector. Specify the path, so I call the model. Import the model, it will create the webcam and show equal to specify the path, so I call the model. I renamed the model to cop instance dot. Create the model, and then from that we can just call the particular method. We specify the except call have confidence